Okay, folks, let's rock and roll. My name's Rob Lalonde, and I'm going to host this webinar today. We're really excited to have Jermaine Chia here from Azure. I'll introduce him in a moment, but we're doing a series of these events. And hey, how about I turn on my camera and just wave at you all? This is a webinar series where we're really focused on the infrastructure and deployment models for scientists with Nextflow. Obviously, we're going to talk about cloud providers. We're going to talk about on-premise schedulers and even Kubernetes down the road. But today we're excited to have Jermaine here to talk about our Azure integration and to tell you about the Azure solutions. As I said, my name is Rob Lalonde. We've got Evan Floden, our CEO and co-founder here, and we've got Paulo Di Tommaso, our CTO and co-founder, and the Nextflow creator online. He's able to take some questions in the Q&A as we roll forward. So everybody, let's just get going. I'm going to introduce Jermaine. He's a principal program manager at Microsoft Azure. I've known him for years. He's got some great experience in life sciences and cloud and HPC, and I'm really looking forward to his talk. So without further ado, and without you having to hear from me too much, I'm going to turn it over to Jermaine to share his slides and get rolling.
Thanks, Rob. I hope my audio is coming through clearly. I'm going to turn on my video as well, say hi to everyone. Evan, Rob, Paulo, thank you very much for organizing this webinar and inviting me to do this. I really appreciate the opportunity. I'm going to share my screen now. Thank you very much. Thanks again, everyone, for your time. I really appreciate the opportunity to speak here, speak a little bit about what we are doing at Microsoft when it comes to genomics. As a way of introduction, I am a program manager in the Microsoft Genomics team, which is part of our Health Futures group. I recently switched over from the Azure HPC team. So, over the years, I've worked with Rob, Evan, and Paulo quite a bit. And I'm really happy to see that we get a bit of traction with like Nextflow on Azure and getting to deploy infrastructure on Azure to run Nextflow pipelines. So I figured I would take a bit of time to speak a bit about what we do when it comes to genomics on the cloud. And so thank you very much again for your time. So I think, most of us on this call sort of appreciate this, but the transformations in like the technology for doing genomics, primarily around sequencing, has just been pretty amazing the last few years. And with the new generation instruments coming with like a much higher throughput, as well as like increased read lengths at a much lower cost per base pair, is leading to this huge expansion in the amount of like sequencing that's being done in terms of like number of genomes or number of base pairs sequenced, and that in Microsoft we anticipate genomics being part of the next wave of precision medicine, if you will, being used obviously today in like fundamental research, but as well as like clinical research, and diagnostics, as well as like drug development. So the team I'm in is like pretty much focused on this aspects, aligning the genomics technologies to how we deliver like health solutions to our customers. But we are obviously pretty aware that genomics is used in a very large range of different life science verticals, including agriculture, as well as like environmental sequencing and what have you. Oops, my screen froze. So, but with this large amount of data that's coming through, we appreciate the challenge that our users or customers face in trying to analyze this data, and store this data. A single Illumina NovaSeq machine generates up to 300 terabytes of data every year. The amount of time needed to analyze this data is really putting data centers in a bind. And it's anticipated that, while we fully anticipated a lot of these workloads will start moving to the cloud, And being able to deliver solutions for customers and running this type of genomics workloads is something that we're paying a lot of attention to. So we want to enable these in different levels. First of all, in building a collaborative platform with like easy access to both open source as well as community tools in terms of data and tools to support different research teams to run their genomics analysis on Azure. Very recently, in the beginning of this year, we joined we joined the Broad Institute and Verily to be part of Terra, and we see Terra as like filling in some of these the features here, particularly around data access. So when it comes to providing automation and scale, we recognize that workflow management, in a sense, like running large disparate like pipelines in the cloud, is challenging. So making this easy for customers and building a lot of automation around that is also another piece of the puzzle that we're trying to fill for our users. And we have a subset of customers that are building essentially working with like clinical samples. And here they are looking for secure and compliant deployments. And in this regard, we have a genomic service that is essentially HIPAA compliant, also covered under our BA agreements to provide this turnkey service to our customers. So we are approaching the genomics landscape in like multiple levels. So I want to spend just a couple of slides just going through workflows and the workload orchestration layers, if you will. So the first one, as I mentioned earlier, is basically supporting the open source community-driven workflow managers. And we see Nextflow as being one of the key ones here. Through this partnership with Seqera, we're really happy to enable Nextflow integration directly into Azure via Azure Batch, the scheduler as a service. Also through our Kubernetes service, and with native integration into blob storage, so that accessing data through blob is pretty straightforward in Azure. We also, work with Seqera to enable monitoring through Nextflow Tower, and the relationship with Seqera is also enables us to provide enterprise support for Seqera to our Nextflow, our customers who are running Nextflow. And the last section I kind of would like to cover is really how we do workload orchestration. Basically, the layer that the workflow managers like Nextflow, Chromewell sits on is a schedulers as well as like a provisioning layer that auto scales the environment for the task that is needed to be ran. There are essentially three main workload orchestration systems for genomics workloads. The first one is batch. You can think of it as a scheduler as a service with all HPC, which all VM resources essentially obviously cloud-based and auto scaling pools to drain the tasks that are in the queue. The other system that we provide to our customers is CycleCloud, which really enables someone to bring your own scheduler of choice into Azure. And we recognize that a lot of the HPC market today is still primarily on-premise systems, and many of our users have built up a lot of expertise and tooling around traditional schedulers like PBS or LSF. So CycleCloud makes it easy for someone to run their workloads in Azure without having to switch out a lot of the underlying scheduling systems. And finally, for our for customers who are using running more cloud native containerized workloads, the Azure Kubernetes service makes it easy for you to create and scale up Kubernetes clusters on Azure. Just a bit of information about Batch. Batch is, as I mentioned, a scheduler as a service. It supports both like basically high throughput and MPI tasks. Batch is deeply integrated into blob storage, which makes it easy for someone to deploy applications as well as like use custom VM images or Docker containers in your batch jobs. There's a wide range of VMs that are supported in Batch. Basically, any of the VMs on Azure runs through Batch, including both Windows or Linux operating systems. This deep monitoring built into the Batch service, and the logs are easily retrievable and are digestible through Azure Monitor, as well as like integrations into the different Batch agents. And Batch is also really built for developer access. So, for example, a tool like Nextflow would interact directly through the Batch APIs to do job scheduling and auto scaling. And this Batch has a wide range of like libraries to support Batch, and we see developer access as being a pretty key component of like the Batch capabilities. So let's skip this. And so accompanying Batch is really Seqera Cloud, which as I mentioned earlier, is a orchestrator for like launching HPC systems. And you can think of it as like a choose your own scheduler kind of like system. We support most of the popular HPC schedulers out there, like Slurm, Grid Engine, PBS, and LSF. And we deploy these both in a cloud native model where the entire cluster sits in the cloud, but also in a hybrid system where you're hooking in Azure resources into your internal schedulers. So you can envision this as allowing someone to build end-to-end HPC environments for genomics workloads on Azure with data on-prem going into essentially blob storage, and if needed, different storage services like NetApp files or Azure HPC cache for higher I/O performance. And users logging into systems where they recognize it could be running Nextflow or running something like Jupyter Notebooks, launching their tasks through Azure Batch, and then providing dynamic scaling and VM provisioning for running the tasks. So we have basically three pillars on how we deliver our services. We want to enable our customers to run any tools of their choice, and also developing basically platforms for collaborative environments and automating their workloads. And importantly, working with our partners like Seqera to extend and deliver specialized services and products to our customers. So that's my last slide. Thank you very much. Evan, Rob, back to you.
Thanks, Jermaine. That was great. We really appreciate it. Stick around, Jermaine, if you would, and we'll hopefully get some questions on your offering as we roll through. Feel free, folks, to put those into the Q&A during the session or wait till the end, whichever you prefer. And Evan, I'd like to turn it over to you to talk about the Seqera Labs offering and what we're doing with Microsoft.
Yeah, thanks a lot, Rob. Thanks a lot for the intro on Batch there. We're super excited to kind of release this. This has been some time in the making, and thanks a lot to the Microsoft folks for reaching out and kind of taking the initiative here. in terms of bringing Nextflow to a whole bunch of new users, of new enterprises who we can really kind of open up to. And we had sort of requests over the years of people who wanted to run Nextflow on Azure and also on Batch, and kind of like making that happen. It's been sort of really exciting for us. So I'm just going to provide a few minutes introduction to Nextflow. I'm sure that many of you are very familiar with it, and then we're going to jump into some demos and some sort of the commercial offerings that we have and some of the enhancements that we have for running these pipelines. So the focus of our company, of Seqera Labs, is really based around Nextflow itself. So it's a kind of open core company. And the values and the kind of philosophy that we have are very much based on that. So the idea that there is these pipelines, when you write them, they can become very complicated. When you have many different steps that you need to parallelize and need to run on distributed infrastructure, becomes a real problem. And that infrastructure itself is also very challenging. So the provisioning of it, the management of it, is also challenging for a lot of folks, particularly who are, have science backgrounds, who have sort of domain expertise, but not so much on the infrastructure side. And sort of related to that is that all of this is taking place now within the context of teams and of organizations who are kind of working together and then really need to collaborate on those resources and then run these pipelines efficiently. So quick background on Nextflow. Nextflow is a few things. So it's both a syntax, so a way of writing pipelines. And in Nextflow, you define code, write it in any language. So this means you can take your existing bash scripts, your existing Perl, Python, etc. You can then orchestrate those tasks, what we call processes, by linking them with the state of flow programming model. And this is a very powerful model that's able to scale to millions of tasks for a single execution. We are very also focused on the containerization. So Nextflow had introduction for Docker way back in 2014. And as part of that, we kind of fits in very nicely with the model, particularly with Azure Batch, where each task can be a containerized task and can be submitted to these services as a containerized job. Finally, Nextflow scripts are all integrated into Git. So you wrap all of that code that you've written into a Git repository and allows the pipelines to be very kind of portable, shareable, but also traceable in terms of everything that you've run. Now, the other part of Nextflow, which is just as important, is the fact that we can run any of these pipelines on any of the different execution platforms. And the separation of these two things is really key to creating portable pipelines, which kind of sounds like, maybe just something which would be nice to have. But what it's really turned into is the fact that now you can have domain experts from all around the world collaborating on these ready-to-go pipelines. And because they're not tied to a particular infrastructure, they can really collaborate, build these pipelines, create production level workflows, which can then be shared with the world, collaborated with, built openly on GitHub, shared and then run by anyone running this. And this kind of community aspect has become increasingly important for Nextflow, and also kind of the growth of these kind of bioinformatics pipelines as people have been adopting workflow languages more generally. As part of that kind of adoption, we've seen a big rise in Nextflow for particularly the last couple of years. And that's driven not necessarily just by the kind of people contributing open source code to Nextflow, but really people developing these pipelines around. So people creating, contributing code, contributing pipelines, and there's been some fantastic communities which have really sprung up around that for doing so. I think where we see that adoption, and it's really much focused in the life sciences, primarily because this is where we've come from. So that adoption is really focused in pharma companies, but also there's a lot of small biotech development going on, kind of very much related to what we said before about the sequencing. And it's also as part of that, the kind of traditional sequencing centers and research institutes who are adopting Nextflow and really using it as part of their daily kind of production, but also research side of it. Just a couple of stories here of where Nextflow has been used. So Nextflow is the key kind of component here of the COVID-19 sequencing effort driven by the UK government here. And as part of that, this kind of the identification of the UK variant was driven by this sequencing effort, where they're really able to manage, this is a pipeline which runs 5.1 million jobs of Nextflow so far, and it's kind of continuing to increase. So just an example of the work that Nextflow has been doing. A little bit on the syntax itself, and there's something like clear decisions that we made very early on that this is focused for scientists, for developers, for people that want to write really parallelized code, but want to be able to reuse existing applications. So you shouldn't have to rewrite your application just because you want to run it in a parallel manner on any infrastructure. And this means that you can very simply take existing command line tools. You can take existing scripts, you define the inputs, the outputs, and then you link those process scripts together with this data flow programming, this DSL, which is kind of the Nextflow syntax. And there you can define those inputs. And this really allows people, say, without a deep expertise in writing parallel programs, to take those pipelines, develop them, and then to run them on any infrastructure. And really running them on any infrastructure is, again, a really key point here. And when we started off, and still today, it's very common to run a kind of centralized cluster orchestration where Nextflow has these integrations with the traditional grid schedulers. So Nextflow is doing the job submission for you to those schedulers, and you typically have a shared file system for running and for this. And if we look at the Nextflow user base, sort of talking about that, we still see about 65% of people are running on these schedulers, typically on premise, but obviously there's a bit of big adoption of people going to cloud in this way. What will also become very common, and this is what we're really highlighting here, is this what we call managed cloud batch orchestration. And here is where Nextflow is able to submit those jobs to a scheduler, but the scheduler is in the cloud and is not managed by the user themselves. This means that the virtual machines are able to spin up, that they're able to scale horizontally, and that the user can essentially take themselves away from the management of those. And this has become really increasingly common. It's become a really nice way because you're able to scale back down to zero. So you really only pay for what you need. At the same time, you have the flexibility to use resources that maybe you wouldn't have access to, and you can really just use those resources on demand. And this is becoming a really common way. And this is what we're going to really stress for the rest of this presentation and what we're going to demo. But also, we also have the ability to run these things in what we call cloud native orchestration, or this is a Kubernetes-like execution, where Nextflow submits each of its tasks as a Kubernetes pod. And then we see this more taken up by customers who are interested in managing their own infrastructure. So those people that want to really define exactly how that horizontal scaling takes place, or they want to define, some of the really specifics about that. They want to kind of build their own system for doing here. And you can use this with AKS, but also you can bring your own Kubernetes to run here. Okay. And talking about this, we kind of see this as probably kind of go toward the future. It's probably not ready for most consumers yet, or for most users yet, but kind of something that they're going to go to in the future. And if we queried our Nextflow user base, and they really saw that this is something that they'll be willing to adopt in the future as it kind of matures. A little bit more on the integration that we have with Azure Batch. And here I wanted to just break down a little bit more and provide a little bit more detail as to what's happening at each of the steps, and kind of how Nextflow is integrating with it to provide a bit of a better picture here. So when Nextflow runs a command, so Nextflow run your pipeline, what Nextflow is able to do is it submits each of those individual tasks to the Azure Batch API here. And this is very much like it's just submitting to a scheduler in that case. Then Azure Batch is able to take each of those tasks, and what we define as a Azure job here is essentially a Nextflow process. So we'll say this is the process that's going to run. And then each process, just like in Nextflow, can run multiple times. So you can have a process which runs once for one sample and 1,000 times for 1,000 samples. Each of those Azure jobs, which we call a process, becomes a task. And the really nice thing here is that those tasks, you can put multiple of them onto a single virtual machine. And the abstraction that we use here is very much similar to the queue abstraction that we have in Nextflow. And here we define a queue, though, as a batch pool. And that batch pool is simply a collection of virtual machines, which is able to horizontally scale. So the definitions here are slightly different words in the way that we use, but the mapping is very nice. And of course, all of this really links in with Azure Blob Storage in very much the same way. So Nextflow is able to stage any input files that are not already in Blob Storage. It's then able to take those onto there. Nextflow will then transfer for each of those tasks which will run the input data from the Blob Storage into the virtual machine, will run on those tasks, and then the output data can go back into Blob Storage. And from a user perspective, it's kind of happening in a seamless way. Okay, how do we do this now? So I'm going to go through a bit of a practical session. I'm just going to show you a few of the options which are specified, and then we'll jump in and do some demos here. So to run with Nextflow, The first thing we need to do is use the latest version of Nextflow. So this is the Edge release. This will be rolled into the next main release here. But in the first case here, I'm just specifying the Edge release of Nextflow. I'm updating it to make sure I'm running that. And we have a couple of things that we need to specify. First is a Azure plugin here. So this is just basically saying I'm going to use that plugin. As part of the latest Nextflow release, we've separated out the cloud executors into plugins. Some of them can contain a lot of code. We want to keep the Nextflow runtime pretty lightweight. So it will just simply pull those as required. You can also pull them offline if you wish. Specify the executor we wish to use. And this kind of main config associated with the process itself. Then we can specify the blob storage. Again, this happens in the Nextflow config. So here you put in your storage account name and your storage account key. And one thing that's kind of a bit unique here is that there's two different connections here. We have one for the storage, where you can have an account name and a key. And the very same thing can happen again for the batch connection. So then you can have a batch account name and a batch account key, and you can enter that information either here, or you can put it in the environment variables, etc. And Nextflow will be able to pull those. The other thing that we can specify is a location, and this is just the location where it's going to be running in Azure Batch. And finally, the auto pull mode, and we'll get to that in a little bit in a moment. But the auto pull mode is essentially going to create that pool for us of those virtual machines, dependent on the resources which are requested by the Nextflow tasks. Okay, how do we actually run these things? So the basic setup is relatively simple. So once we have specified those configuration options I showed you before, and we have our Azure Batch configuration set up, we specify Nextflow run, the pipeline, and here I'm just gonna make the point. I'm gonna make sure that my work directory is gonna be in Azure Blob Storage in that case. And then by running that pipeline, I'm gonna run it. So we can just jump over to a new screen here. And I'll show you how that works, and we can run through some pipelines. So here I'm just going to enter in the Nextflow pipeline I'm going to run. You can see I have the config here. I have a location. I have the key, which is an environment variable. I have a pull mode. This is going to scale to 2 virtual machines. Again, I have the storage, and then I have the executor here as well as the work directory. So a few settings that are kind of, if you're familiar with Nextflow, you should be hopefully familiar with how these things work. And now I'm going to run this pipeline. And importantly, I'm going to run it remotely. So it's going to be running, pulled from GitHub, run that pipeline, and then we're going to monitor that through as it goes. So we launch the pipeline here, and you can see it's going to pull latest version here, run the pipeline, pulling it from remote, and we're going to be able to see the different processes running here. This is a pretty small pipeline. It's only got about 4 different steps to it, and each of those steps runs a couple of times. So we have an index step, fast QC, quantification, multi-QC, kind of standard bioinformatics pipeline. And then as part of that, if we want to go monitor this, so we can go through now and see what this looks like from the terminal perspective. So if I was to go in now into the batch console, we would see that inside batch here, we have this group which has been created, and this group here is associated with a pull. So we can see, if I was just to quickly refresh this, hopefully it doesn't kick me out. Okay, we can see we can refresh this, and you can see that the virtual machines have kicked off there. I could go back in here and see the different pools that are available to me. So just do a refresh on that. So that's the pool ID, which contains those virtual machines. And you can see that I have 2 of them, and one of them is running. So one of them is running that task, which we have. One of them is idle in this regard. What we can also see is the blob storage, which is another important part of that. That's where those input files and where the intermediary files are going to be located, and where they're going to be operated on and moved around. And if we go into the storage here, you can see that I have a storage container called my data. When I access that, I can see that this is the typical Nextflow scratch and work directory. So this work directory contains all the intermediary files here. If I was to jump into here, I could see the work directory. I could see, in this case, a liver sample, which we've been running, and you can see the different commands. So it kind of operates in a very kind of Nextflow native fashion. And from a user perspective, sort of very little is sort of required for launching that pipeline. Okay, we'll just jump back quickly to the terminal, and I'll kind of show you that one's complete there. So you can see that was pretty quick. for launching that pipeline. And we find that the system is very responsive, that it is able to run very large pipelines in a very efficient manner. There's very little waiting, and it can kind of feel almost like you're running on premise, and in some cases even faster for larger pipelines. What we can also do is do a resumption of that pipeline. So I can say resume here. In this case, I will cache those tasks which have already been pre-executed, executed previously, and those tasks don't need to run. And you can see that you get, again, a very fast execution of that. And this is just a kind of to highlight how fast this is for running it. And I know we mentioned Cromwell a bit before, but if you try and compare this to sort of running a Cromwell execution, you'll see that Nextflow is just so much faster in this regard. Okay. So that was a kind of, hopefully a very basic overview of how you can run Nextflow with Azure Batch, how you can connect in the blob storage, and kind of run a basic pipeline. But let's now look into a little bit of the more technical details of how we can run this and what we kind of need to do and how we can define this. So when we submitted, though, when we ran that pipeline, to think about a few things that happened. So for each Nextflow task, there was some information which was transferred, which was sent to the Azure Batch API. And if we imagine that we had a process here, say a GETK task, we could define some things. So we could define, for example, a container, which is basically going to be where the task is going to be executed. We could have some memory, some CPUs, etc., some inputs and outputs like you typically would. So when Nextflow submits each of those tasks, it's able to convey to the Batch API the amount of memory, and therefore it's going to put that task onto a virtual machine, which obviously has to be provisioned in the pool. The CPUs as well. Again, you can have multiple tasks onto those single virtual machines, which can be very efficient if you have many different tasks and you want to put those into a virtual machine that makes sense. You also can have the script, the wrapper script, which is the part which is Nextflow is going to transfer the files from the blob storage. So it's going to say, these are my inputs, move them from blob storage to the virtual machine. And then you also have the task command, which is essentially what is executed, the traditional part of your script, your command line or the execution part of your task. Finally, you have the container, which is going to be defining exactly the execution environment for that task. And then you have the work directory and the pool, which is specified here. And I'm going to go a little bit more into the pools because it's maybe a new concept for people, coming from Nextflow. And I guess what someone don't get too scared about this concept, even though it seems a little bit different from what you're used to. It's actually a very powerful concept, and we've been finding in our work it's been very useful. So the pools themselves, what we wanted to do was essentially build a way that these pools could auto scale, and they could be built on the fly. So like how we said before that Nextflow can define and send a particular amount of CPUs or memory for a given task, we also wanted to be able to build those pools on the fly. So we built in a mode which we call auto pool mode. And as part of that, Nextflow will build that pool based on the resources that are requested. You can also, if you wish, you can kind of override that. You can specify the types of machines which should go into that pool. You can specify the size which they can scale to. So, being able to going up to 10 and be able to do that. And by default, if you don't specify the CPUs or memory, we're going to be using this one compute node of the standard D4 V3 type here. What's also super important, though, is this concept of a named pool, because very often maybe you have a heterogeneous pipeline that some of these tasks are going to require a certain amount of resources, some of them are going to require GPUs or some different kind of memory intensive resources. So for those situations, you maybe want to specify the different pools themselves. And here within pools, we can create what's called a concept of named pools. And this is kind of somewhat important, but the most important thing is that those named pools link through directly to a queue directive in Nextflow. So if you specify a queue, in this case, as part of your Nextflow process, which is called foo, then those tasks will be submitted to that pool. And this is a kind of really nice way that we can link up these two concepts and really keep the code kind of very harmonious in terms of the Nextflow writing, and also able to kind of work in the same sort of batch manner. What we can also do, which is really nice, is from a single Nextflow execution, submit a workflow and have some of those jobs submitted, for example, to Azure Batch, and some of those can be submitted to Slurm. So Nextflow has both the ability to stage data across different environments. So this could be local or into your Azure Blob storage, but also within that pipeline, a single task could be submitted to Slurm. And then you say, for example, you need some resources which you don't have in Azure, you can do that as well. And this can be simply specified from the config in the exact same way. So you can choose the executor at the task level or at the process level, which provides you a lot of flexibility in running these pipelines. Increasingly, this is becoming important where the data and the location of the data becomes important, and therefore you want to be able to mix and match your pipeline execution depending on the location of that data. So far, just really big kind of overview of Nextflow, what we're doing with Nextflow, what can we do with Azure Batch, and so we're really excited about that integration. It's really kind of the kind of final piece in the puzzle in terms of, for us, in terms of the managed batch services, and really excited to have Microsoft on board and to be partnering with them for that. We built Nextflow as a command line tool. As I say, it's been around since around 2014 now, so quite a long time. And as part of that, though, we have many conversations with users and sort of understanding what their kind of pain points are in terms of launching these pipelines. And a lot of that was really associated with the fact that Nextflow was designed for workflow developers, for bioinformaticians, and there's a kind of whole set of use cases of users who are somewhat left out from that. So as part of that, we wanted to kind of understand that those pain points and build for those. And this is what we developed Nextflow Tower for. So we're trying to think about what's the issues here with building and kind of deploying on Azure or any kind of managed batch service. So there is challenges with deploying these applications as they become complicated. You do have to manage that infrastructure. Some people are not comfortable with the command line. Some people don't want to provision that infrastructure themselves. Also ways of having users or developers, I should say, build these applications for users in different use cases. So having an integrated environment for those pipelines to be launched and a kind of common use and a common way for developers to write them, as well as doing all of this within inside the idea of a collaborative, secure environment where people can collaborate, where people can share pipelines, they can share computer environments, and they can really work together in terms of focusing on the science here. And this is what we focused on Nextflow Tower for. So initially it came out, and I'll show you first, as a monitoring tool. So monitoring your Nextflow pipelines. You can also launch these workflows. So be able to now execute those pipelines and execute the Nextflow runtime from Tower itself. The team organization is obviously very important for coordinating all of that work within the context of a team. And now we've been building out some more advanced things on the terms of the shared file systems, in terms of optimization, in terms of really focusing on building specific containers for different platforms, and kind of building those features in for workflow developers, but also for users to run. So I'll quickly jump through now and show you how to do basically the same thing, but kind of in an automated fashion with Nextflow Tower. So going back to my screen before, Nextflow Tower it's a full stack web application. You can try it out at tower.nf. You can log in there with your GitHub credentials if you wish. We first started this as a monitoring tool. So you can monitor the application, you can see the command lines that have been run. On the left-hand side, you can see these different executions which I have here, the ones that fail, ones that run. And then I have information, for example, on the execution, the status of the jobs, the processes, the aggregate statistics here. So this would be including things like the cost. So we have a database on the back end, which includes all of the cost of those resources for determining the particular run times and the particular workflow costs. You can also dive deeper into the individual tasks here. So jumping into those, and I'll show you that in a moment, accessing the logs for a particular task, which is really important for very big pipelines that are running in a distributed manner. I showed you before the blob storage. Now imagine that your pipeline has 10,000 tasks. Those tasks and those logs are split across 10,000 different working directories. Trying to understand exactly where the error is and what the error is kind of telling you can be a really difficult thing. And here we provide a unified way to access that information independent of your execution platform. You can also do things like profile the pipelines that are running here. So I can see CPU usage, or in this case, the RAM, the memory that I've been allocating. So these tasks are relatively well optimized. You can see I'm using 90% or so, but these tasks here, maybe I should specify less memory, and then I can do this. And we're trying to build that into the system so that it happens in an automated fashion. Something that we'll have out later this year is that optimization built by learning on the system that exists. Okay, let's think about now going back to how we can run this with Azure Batch though. All of this operates on the concept of what we call compute environments. And these compute environments are very much similar to like a Nextflow executor. So they're actually using Nextflow executors in the background. And we can create a compute environment for Azure Batch exactly like we did before. So I can go in here, I can create a compute environment, and Nextflow Tower supports all the major ones that Nextflow supports. So I'm going to create a new compute environment here. I'm going to call this one Azure Batch. I'm going to select the platform that I want to run on here. I can put in my credentials if I wish. So this would be the credentials from, in this case, it would be your Azure credentials. I can put in a location. It uses the API, so you don't have to remember these things. You kind of have everything that's available to you. So we are going to do this in West Europe. I can see now the pipeline bucket. So you can see that this is the exact same one I had before. Again, API looks up this for me. And I'm just going to use manual here because I already have a compute pool set up, and likewise it will use the same one. So this is the exact same thing that was created by Nextflow before, and I can just use this in this way. So a few options here, set that up, and now this compute environment is available to me to launch those pipelines. I can launch now any Nextflow pipeline into that environment, or have any of my colleagues who logs into Tower do exactly the same thing. So what does that look like? If I'm a workflow developer, I have this option here of setting the environment, the one that we just created. I can choose a pipeline that I want to launch. Let's just run the same pipeline for consistency here. Again, I could choose a revision. This would look up the Git API. So for example, the commit versions or the tags that I have. But the main thing that we need to do is just simply launch that pipeline. And when we launch that pipeline, we can now monitor it. It goes through to the monitoring screen, as you can see here. And we could now dive in and see particular information. We could like follow the execution log as it comes along. We could dive into the individual tasks and jump through and follow that through. So depending on when I've last run the task, it might take somewhere between 5, 20, 30 to a minute or so to launch that pipeline. You can see this is now launched. If I go to the execution log, I can follow this information here. You can see this. And what's really cool about this is I can dive into a log. So I could dive into, say, the index, jump into here, and then follow the execution log of that particular task. So this is an incredibly powerful thing for being able to connect into the very distributed systems. And again, this works across all of the platforms that we support for doing so. I could download the log files here if I was interested in that. Or I could also even, when this pipeline is complete, I can download a timeline, get sort of various information about that. What we have coming out in this regard is the ability to specify specific outputs which get put there as well. So that's kind of a brief demo on how we can launch these pipelines. Again, relatively simple here, simple to set up. What we're really going for Tower, though, is to be able to, as I said, build this in the context of teams of what we call different user types. It's true that not everyone is a workflow developer or a bioinformatician or a developer who wants to use the terminal. And therefore, we wanted to make this system much more accessible for organizations that want to use it. So we have this, now the latest features out in Nextflow Tower have concepts of these. So they have a concept of an organization. So you can create different organizations within the application. You can create workspaces, members, teams, etc. You can even have external collaborators who you can join into your environment and they can access that. But the main thing we've been building this under is this concept of a workspace. And a workspace is a collection of the entities I showed you before. So inside here, I can see that I have RNA-seq benchmarks. Here I have a launch pad, which I'll get to in a moment, but the same features as before. So runs, actions. I have credential management here, so I can add in different credentials. I could add in, for example, my GitHub credentials if I have repositories or pipelines which are in private repositories. I can even connect in my SSH credentials to SSH into a machine to run that. From the Launchpad here, and this is what we're really excited about, this opens up the Nextflow ecosystem to people who don't even know anything about Nextflow, and they don't need to. So from here, you could jump into Nextflow Tower. A workflow developer could specify this is a pipeline. They can publish it from the context that they are. And a user simply comes in, selects the pipeline they wish to launch. A pipeline is simply a Nextflow workflow plus a computer environment plus some pre-configured settings, basic parameters, and that becomes available to them. So they simply can specify some drop-down values if they wish. They could choose Boolean values, integers, etc. They can have help screens in here. And all of this is specified via open schema, via the JSON schema for which was defined by NF Core. So all of the NF Core pipelines have this by default. I could upload a params file here if I wish. And I could simply launch that pipeline. The other really important thing of this is having sort of different roles associated with this. So you can see that I have a collaborator here. So I could give him a role where he's simply able to view the pipeline. I could give Rob on the call the role as a kind of owner here. And these roles have different abilities to do it. And this is, again, going back to the idea that we're going to have different users who are going to interact with the system, and therefore they're going to have different requirements. Final thing on this is the idea that we can create new pipelines. So as a workflow developer, I can come in and create a pipeline here. I can simply go onto GitHub, take in this case, description. I'm going to enter in that description. I'm going to choose a computer environment for launching that pipeline. I'm going to choose a pipeline that I want to launch. I'm just going to take this from GitHub. And from here, that pipeline then simply becomes available for anyone in my workspace to be able to select and to launch. And the nice thing is that all of that input file, the input is defined by this Nextflow schema here. So you can see this is the equivalent in Nextflow of -- input or -- UGG type for that. Final things on this before I go. All of this can be controlled from an API. So the whole thing is an open API for connecting in. We have customers who are simply building on top of this. So using Nextflow as the orchestration engine for their underlying execution. You can see there's a lot of sort of space on where to go here. And obviously that's become, it's been out for about a year and a half now. We've been very, very pleased with the response and the kind of usefulness of this for customers. Also, the way it's deployed. So this is a customer deployed solution. So you say you can deploy this on your laptop, you can put it in your cluster, you can put it in the cloud, deploy with containers, Kubernetes, etc. So I think I'm pretty much gone a little bit over time, but I'll stop sharing the screen and we can go through a couple more things here in terms of final tips and then some questions. So in summary of all of that, so you can run Nextflow, multiple ways. Hopefully you've got a flavor of what it looks like now running the pipelines on Azure. Things to think about in terms of when you kind of do this or trying to scale this up is that the tasks themselves should be sensible in size. And this means that you have to think that each task will be submitted. It should not run for half a second because you're going to get some inefficiencies there. Also consider when you're moving the data around that the data is in the location where you want to run, and you can use different executors for that, computer environments. Also selecting the specific instance types depending on the workloads that you have, and you can kind of profile those with Nextflow Tower, understand a little bit more about that. And then if you start to think about the real small optimizations you can get, hosting the containers in the Azure Container Registry, as well as optimizing those containers for being specific for the types of workloads that you wish to run. So I'm going to finish it there, and we can jump into some questions that we have if anyone's got anything.
Thanks, Evan. Thanks, Jermaine. I don't see anything in the Q&A as yet. Does anyone want to put up their hand and ask a question? Or please fire it into the Q&A. We'll give you 30 seconds or so before we wrap up if you have any interest in asking anything. Looks like we've got a quiet bunch today. Maybe we answered all the questions. Well, that being the case, I'd like to thank everyone for attending. Jermaine, thank you very much for joining us in your presentation. And of course, thank you, Evan. And we'll see you in the next infrastructure webinar we do. And thanks, everyone. We'll see you again.
Thanks, Rob. Thanks, Evan.
Thanks, everyone. Have a great day.
Cheers.